Hi! Today I'm going to show you how to solve problem 26 from the 2019 Math Kangaroo grades 5 and 6. Here's the problem. Emily took selfies with her cousins. Each of the 8 cousins is in 2 or 3 pictures. In each picture there are exactly 5 of Emily's cousins. How many selfies did Emily take? So here I drew some examples of what the selfies might look like. Here we have Emily, and Emily is going to be in all of them because she's the one taking the selfie. And then there'll be 5 different cousins, and it's random who the cousins are. But we know if we look at this green one, for example, that the green one is in 2 pictures here. And the green one could also be in a 3rd, so we could have like some other picture in the middle somewhere here that has the green one. But this whole picture here, we don't know if it exists. It's a mystery because we don't know if the green one, this particular cousin, is going to be in 2 or 3 pictures. So we can say that the thing we're looking for, which is the number of selfies, we can call that x. That's just an unknown, and that's what we're looking for. So we'll say x is the number of selfies Emily takes. So if we look at the problem, the information they give us is that each of the 8 cousins is in 2 or 3 pictures, and that there's 5 cousins in each picture. And they don't tell us much about the number of selfies that are actually taken. But we do know a bunch of things about the cousins, and that will lead us to be able to find out numbers for the total number of cousins. For example, what I mean by the total number of cousins here is if we would count, there's 1, 2, 3, 4, 5, 6 cousins, and then in this picture we'll count these cousins again just because we're counting the total people. We don't care if they're the same person or not. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 people here. So when we're counting the total number of people, we can ignore Emily and we don't have to count her. And that's because Emily is going to be in all the pictures. And so we don't really know how many times she'll be there. For the other cousins, we know they're going to be in either 2 pictures or 3 pictures. With Emily, we have no idea. She'll be there X times, but it's easier if we just ignore her because we still know the number of cousins in the picture without her. So let's ignore Emily for now. And we know that there's X pictures. And in each of the X pictures that are there, there's 5 of Emily's cousins. So in each of the X pictures, we have the total number of cousins times the total number of pictures with those cousins. So it's X times 5, 5X. There are 5X people we can count in all the pictures. So what else do we know about this number 5x, the total number of people we can count? Well, we know that each of the 8 cousins is in either 2 or 3 pictures, and that gives us bounds. Because suppose we want to minimize this number 5x. Well, what's the smallest that number could be in this problem? So 5x is also going to be the sum of the number of times each cousin appears. Because if we count the number of times each cousin appears and we sum those numbers for all the cousins, then we'll have counted all the people in all the pictures. So if we want to make that as small as possible, then we want to make the number of times each cousin appears as small as possible. And the smallest that could be is 2. We're given that in the problem. So the smallest number of people we can count is going to be 8 times 2, because 8 cousins times 2 appearances is the smallest, and that's 16. Similarly, we can find an upper bound by doing the same thing with 3 pictures. So if we're looking for the largest number, we want to maximize the number of times each cousin appears, and the biggest we can make that number is 3. So the maximum is going to be 8 times 3, or 24. So we know that these are the bounds, and we know that this number 5x has to be somewhere in between them. So that gives us that we can write that 16 is going to be less than equal to 5x, and that's less than equal to 24. We know that 5x can either be equal to one of these bounds or somewhere in the middle, if we have some cousins that have 3 and some that have 2. So we know that x is an integer, and we know that because you can't take half a selfie or a third of a selfie. That doesn't make any sense. You can either take like 1 selfie, 2 selfies. It has to be an integer number. So we know that 5x is going to be a multiple of 5, since it's 5 times some integer. So if we look at all the numbers between 16 and 24, there's only one integer that's divisible by 5 in between those numbers, and that's 20. And so that means that 5x has to be 20, because that's the only multiple of 5 between 16 and 24. So now we know that 5x is 20. If we read the problem again, the thing we're looking for is the number of selfies taken by Emily. So we know that that's x, because that's what we set x to be. So here we'll have to solve for x to get the number. And we can do that by dividing both sides by 5. And so here we have 5x divided by 5. So it's 5 times x divided by 5, that's just x. And on the other side, it's 20 divided by 5, and that's 4. We can do this because it's just doing the same operation to both sides, and we're allowed to do that. And so x is 4, x is what we're looking for, so the answer is B. Thanks.